you're going to find threats and vulnerabilities within your systems almost immediately after plugging in these systems.
Welcome everyone to the Industrial Security Podcast. My name is Nate Nelson. I'm here as usual with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and the guest of today's show. Andrew, how's it going?
I'm very well, thank you, Nate. Our guest today is Enrique Martinez. He is a technical solutions architect for OT security at WWT, Worldwide Technologies. And he's going to walk us through today some issues that he runs into that we probably all run into when we're deploying OT visibility solutions.
Then without further ado, here's you speaking with Enrique.
Hello, Enrique, and thank you for joining us. Before we get started, can you say a few words about yourself and about the good work that you're doing at WWT?
WWT is a $15 billion global technology solutions provider. We work with about 80% of the Fortune 1000 companies in consultation, design, test, procurement, and implementation of technology solutions to modernize and digitize the business. This ranges from data center to cloud to the pole top, substation, or factory floor. We're the largest minority-owned business in the country and often the largest company people haven't heard of.
So thanks for that. Our topic is, issues that arise when deploying OT visibility solutions. Can we start at the beginning? In your books, what is an OT visibility solution and why do people deploy these things?
When we're talking OT security, historically, we have had a big gap versus an IT environment where there is no capability of identifying your assets other than, doing walkdowns, going physically to a site and walking down the racks, categorizing the equipment and putting it in a spreadsheet. So over the last few years, technologies have been catching up to this problem where in a passive manner, we're able to monitor the traffic going through a network and identify the assets that are communicating within those OT networks. Passive is a very important term because, it is not disruptive. Often these systems are very susceptible to, I would say, interruption or interference by other traffic going through the network. So the preferred method is usually to go passively. The other piece with this is, we're able to then gain a visibility of those assets and not only determine what the asset is, but what it's communicating with. As well as vulnerabilities that are intrinsic to those devices based on what we can surmise from that traffic, as well as determine any active threats that are present in the environment. This is all done through a deep packet inspection methodology that each solution has.
And, our topic is deployment issues. It's problems that arise when we are deploying these solutions. Can you talk about that? What kind of problems do you run into?
I think the first one that's the most notable is requirements. Requirements definition is often the most important piece of a project. And if not done properly, the whole project's going to go off kilt, if you will. One of the issues is tying those requirements to specific business drivers. More often than not, what I see is really usually a copy paste of the features list of a specific solution based on marketing material, rather than a good defined requirement based on business needs. For example, if we're talking about identifying assets, right? So I will get something like, well, we need identifying assets and vulnerability detection, for example. When we're talking vulnerabilities, keep in mind that many of these requirements are often drawn out by the IT side and they're being pushed to the OT side. Um, they're thinking active scanning, right? So when we're talking active scanning, you have two methods of doing this in the OT side. One is just performing a regular vulnerability scan, which more often than not will cause issues with those systems because they don't have the robustness to withstand a proper vulnerability scan, looking for active exploitable vulnerabilities. Or once you do an identification of the system, you know what kind of system it is, what protocols it utilizes, then you can do a directed or very specific querying of the device, where it will do a safe check. It'll query the device, gather information about the device, and then report it in a non-disruptive manner. So this is one of those pieces that, it's very important to define what you're looking for, because you don't want to just go, yeah, we want to be able to scan the device and then put a vulnerability scanner without proper policy and start causing outages and issues in your factory floor or in your grid. So another issue that I've seen with requirements is, often we have, let's say, CMDB or SIEM systems, and the customer will say, well, we need the ability to integrate with, the third-party platform that will be like a CMDB. Well, which CMDB do you have? Do you have ServiceNow? Do you have Remedy? Because that will probably make a difference into the tool selection or the solution selection, because some integrate better with ServiceNow than Remedy and vice versa. And we want to be able to maximize and optimize what we're deploying to, for one, make it operational as quickly as possible, and second, to reduce the overhead of managing this solution.
So, Nate, a word of clarification here. Enrique said the concern with requirements is that they don't reflect business needs. He gave a couple of examples. I checked for them afterwards. I think the word that would help here is specific. Requirements need to be more specific than he's seen in practice. If the business need is to figure out what level of firmware each of the PLCs has, saying, do active scanning could mean, throw exploits at the device until it falls over and come back with a list of vulnerabilities, which of course you can't do in a production environment. That kind of, if the business need is to figure out level of firmware, ask the device politely, log into it, ask politely, find what the level of firmware is. That's the kind of active scanning that's needed. And, his second example was connecting to, let's say, a SEM. If you have a SEM deployed already in your security operations center, you're not going to change it. You want your OT system to be able to connect to your SEM. So be specific about what you have, because there's products out there that connect to 6 different SEMs, but that'll do you no good if it won't connect to your SEM. So I think his key business need, means be more specific. Okay, so requirements need to be specific to the business need. I get that. What else do you run into?
Often we see an issue with properly scoping the project. And when I'm talking to scoping the project is, we've defined requirements, we've identified a solution, we're ready to go deploy. Prior to deployment, we need to do our homework. And oftentimes I see, whether it is from the business side, the customer, that they're eager to start the project, or whether it is a sales team that's eager to close the business, proper scoping of the actual project is not performed. When I talk about scoping, it's, there's sensors that need to be deployed in the network to be able to accomplish the task of identifying whether it is assets or threats. But these sensors need to be properly sized. By properly sized, I mean, one, be able to support the traffic going through it, to be able to perform the deep packet inspection, and the other piece is, be able to size it enough for the number of assets that we're going to be identifying through it. Many times, if you don't get that number, you're just gonna have issues when you're deploying. Either you're gonna size it too small and you're gonna be missing traffic, or you're gonna size it too big and you're gonna have unused resources and really it's costing you more, which it's not optimal.
Now I'm a little confused. I mean, if we're doing an asset inventory and we want to use, tools to do the asset inventory, we do the asset inventory in part to find out how many assets we have. But if we need to know how many assets we have before we can do the asset inventory, do we not have a chicken and egg thing going here?
Yes, we do. And this is where, I'd say we need a rough order of magnitude of how many assets we're going to be monitoring rather than an exact number. And, I'll give you an example. I have a project where, I asked, okay, what's the number of assets that we're going to be monitoring? And the answer was about 1,000. But when I start looking at, at the different business units based on the experience that I've had in the electric sector, it's an electric company, I can tell you that there's many more than 1,000 assets. So this is where I go back and say, okay, you said 1,000 assets, you have, let's say, CTGs, you have generation, you have distribution assets, you're talking possibly smart meters. There's going to be way more than 1,000 assets here. We need an approximate number of assets. So this is where I go back and tell them, okay, go each business unit and give me an approximate number of assets that you're going to be monitoring. If you're doing NERC SIP, you will have a spreadsheet with those numbers. If you're not, then it's a heavier lift due to the fact that, there's no requirements in distribution necessarily to keep an asset inventory.
Cyber attacks with physical consequences more than doubled in 2021. For industrial victims, the most common consequences were production outages at multiple sites. Most of the attacks were ransomware. And 2021 saw the first cloud-based ransomware attack. That attack compromised 1,500 businesses in the space of 45 minutes. These and other insights are included in a new threat report, co-authored by Waterfall Security Solutions and the new ICS Strive Industrial Incident Repository. For your copy of the report, please visit icsstrive.com. That's ICSSTRIVE.com.
Andrew, implicit in the question that you asked Enrique there was that some organizations might not even have that sort of rough estimate of their systems in order to take part in this asset inventory process. I'm wondering how often that's actually the case. Like maybe it's an industry by industry thing or a public-private thing, but how many organizations really don't have that much of an idea of what they have within their networks?
Well, the answer is it depends. Enrique gave the example of if you're governed by NERC SIP, then you already have an accurate inventory and you've probably done it by hand. And the reason that you've got a spec out for an inventory system is so you don't have to keep this number up by hand. But in lots of other cases, you don't really know. If we're talking, he gave the example of smart meters. You might have 2.5 million smart meters in a big city. And the problem is if you don't already know how many you have, getting some kind of estimate is hard. I mean, it's not like you can walk down the street and count every meter on every building. It's impractical. You gotta start with something. If you're in a refinery, the refineries, the very small number of refineries I've been in, all of the programmable logic controllers are sitting in the server room. You can walk through the server room and get an approximate count. And his point is do that. If you're talking about, automobile manufacturing or, consumer goods manufacturing, you might have a factory with 1,000 machines in it, half of them robots. And you can go and count the machines, but the trick is to have an idea of how many computers are embedded in each machine, because each of them is going to count as an asset in your inventory system. So, it's tricky. I mean, I'm reminded of an analogy. I was working at Hewlett Packard. We had built we were selling and supporting a big a big iron control system product was used to automate very large processes. We were automating the water distribution system, or really upgrading the water distribution system for a large city. And I remember, working with the services contractor, the engineering firm that was doing this. And, we were talking about scoping, how much of each part of the product was going to need to be bid into the quote we were submitting for this project. And, the question came up, how big does the real-time database need to be? And, the engineer said, Andrew, he said, the request for quote says there are 400,000 sensors in the system. 400,000.0. And I went, really? That's a very round number. He said, yeah, it means they have no idea how many sensors they have. So this is a common problem in the engineering world. And, I guess what Enrique is saying is that it comes up here. You have to have an idea, or you're going to wind up, severely over or under scoped. Okay. So we talked about, problems with the specificity of requirements. We talked about scoping for the asset inventory. What else do you run into?
So we talked about sizing of sensors in relation to be able to support the amount of assets that we are monitoring. The other piece, or the other side of this, is sizing of sensor in relation to the traffic volume. Does the switch have enough throughput? We don't want to overload the switch, especially if you're utilizing RSPAN, where you're aggregating traffic from switches lower in the architecture to a central switch. You'll oversubscribe it. With the problem with that is, if you're utilizing your production network, you could drop critical traffic for your operations, or you could be dropping traffic going into the sensors for the purpose of threat detection, in which case that's not beneficial, because you're going to be dropping traffic that's essential to your security operations. If you're utilizing a sensor for, primarily for inventory, dropping the traffic is not as critical, because every time you do a pass, you're going to be able to pick up on those assets.
I followed some of that, but so RSPAN is where we take span ports from sort of other switches and aggregate them into a single span port, so we can run that span port into the OT intrusion detection sensor. But you had two concerns. One was that the network switch itself, the sort of the high level switch, the one that's doing all the aggregation, could become overloaded, and a second one, that the span port could become overloaded. Now, I can understand that the span port would become overloaded. It's got a limited speed. It's generally less than the speed of the bus on the switch. But I thought that modern switches, correct me if I'm wrong, I thought that modern switches, you could basically run every connection on the switch flat out at 100 megabits each way, or a gigabit each way, and the backplane would tolerate it. Is that not true? Is it really possible to overload the backplane?
Well, often in OT networks, you have really old hardware, might not be modern by our standards, so you will have and you will encounter switches that are not up to par to be able to withstand that type of traffic.
Okay, and I'm not sure I caught you. You made a subtle distinction there, something about dropped packets, being more important in one context than another. Can you go through that in a little more detail?
Yeah, sure. So when you're talking asset inventory, the asset's going to be communicating continuously or periodically. If you don't get that in that traffic dropped because you're oversubscribing. Well, that traffic there's a chance that it's going to be gotten on subsequent communications, right? So to me, it's not as critical, because you will eventually catch it in the inventory. There's multiple passes, you're eventually going to catch it. Now, if you're talking threat detection and you have an active threat that's actively communicating right now, and you're dropping the traffic right now, you will probably have a very slim chance of catching it later on, if it doesn't happen later on, right? So it's really critical when you're looking at threat detection and security operations for be able to eradicate a threat, uh, that you are able to capture all the traffic that's going on through that network.
You mentioned as well that you might have to upgrade switches in the plant. I mean, is this something you can do while a typical plant, whatever it is running?
Yeah, usually you don't, because you will have critical communications going through those switches. Usually they're lower level switches that manage the traffic within a system in a plant. And you don't want to interrupt those communications while the plant is operating. So you will usually have to wait for an outage to be able to do that. If the switch replacement is not an option for whatever reason, there's also the option of installing a network tap to be able to gain visibility into that specific segment.
So Nate, Enrique went through sort of a lot of stuff there. A couple of the takeaways I took from that, the things I learned. I try to learn something every episode. Enrique is saying if you want maximum visibility into your networks, especially for the intrusion detection portion, you want to see everything. You basically want to see all of the traffic on all of the switches, especially the traffic on sort of the lowest level switches, the ones that are serving the programmable logic controllers and the other devices that are sort of directly connected to the physical process. If anything goes horribly wrong, it's those devices that are going to cause things to go horribly wrong. They're the ones that control the physical process. And his point was that, it's not enough to, monitor the traffic in the distributed control system, the DCS or the SCADA system that's communicating with the PLCs, because often the PLCs, the fancier ones, are communicating with each other on these low-level switches, and that traffic never leaves the switch. It's inside the switch. So, he's saying maximum visibility means you got to connect to every one of these switches. And, I asked him which of these switches tends to be the oldest. And he said, look, it's the ones closest to the PLC. It's not that, in my understanding, it's not that all of the switches close to PLCs are old. I mean, at some point you upgrade the PLCs, you put new stuff in. But the high level control systems, the stuff where there's, the HMI, the historians, these systems tend to be upgraded much more regularly. And when they're upgraded, the hardware is upgraded, the software is upgraded, the switches are upgraded, everything's upgraded. The stuff that tends to be left alone the longest is the stuff that's closest to the physical process. And so he's saying, where you find these old switches that need upgrading is in the PLCs. Exactly where you want to monitor this stuff. And, the last point I took away there, he went through it quickly, was, if you want to replace one of these switches way down in the PLCs, yes, you might have to shut the whole process down or wait for the next scheduled shutdown to do that swap out. But you might not even be allowed to do it, because the vendor of those PLCs that are doing the, talking to each other might have said, this is the only switch I support. And it's an old model of a particular brand, and you can't upgrade it without upgrading all of the PLCs. And this is where you have to step in and say, well, if I've got critical communications down there, maybe I need to use taps instead of a mirror port. Taps are clumsier because they can only give you sort of one wire. They can give you visibility into one wire at a time. But you do what you can. So that's insight for me. I'm familiar with people doing all sorts of intrusion detection on the IT networks and on sort of the high-level SCADA systems that are closest in the architecture to the IT networks. This is insight for me. The difficulty of getting that kind of visibility deep into the architecture closest to the PLCs. Okay, so that's a fair number of issues. Is there other stuff you run into?
Yes, one of the pieces that I'd say we often don't think about is the management cost of a solution. This is something that it will vary from customer to customer, but there's always going to be certain type of cost associated with implementing a solution like this. It's usually around the management of the solution. You have to actively manage it. You cannot just put it there and expect it to work. The other piece is, doing the proper tuning. It's in all for all intents and purposes, this is an intrusion detection system, and there's always going to be alerts that are false positives or that are normal occurrences in your environment that are going to need to be either suppressed or tuned out. And for this, we need knowledge of what's going on in the system. This is where ensuring that you have the right stakeholders involved pays off. And this is where we're talking about engineering, the OT side. They know their system, they know what's normal, and they're able to help you tune this and optimize it to ensure that in the future you don't have a SOC analyst that's going crazy with multiple alerts for normal traffic. And the problem with that is, and we've seen this in the industry a lot, is that eventually you start ignoring these alerts, and then you might miss something that's really serious.
Okay, I get the tuning out false positives. That makes sense. But you mentioned management, and what exactly is management? When you say you don't account for management, can you give me some examples of what kind of, I don't know, labor or other costs are involved there?
Yeah, well, usually it's going to be, from the get-go, and this is going to be more during construction than anything else. Do we have the available wiring? Do we have the available power to run the sensors, so on and so forth? Once that's complete, your construction, now your operational is, the care and feed of the sensors. Some depending on the solution, some sensors require a little bit more interaction to maintain them and keeping them running, as well as updates, for example, and then the other piece is going to be your costs for maintenance, your licensing, right? Those need to be factored in. Especially, we're talking about an OT project that's usually driven by IT. It is paid by OT or paid for by OT. And the problem with OT is that there's that big conversation about O&M versus capital costs. And it's a lot easier for the OT side to pay capital. So you want to maximize the investment. So how do you implement it from the get-go to maximize that investment through a capital expense rather than going through an O&M in 3 years and having to pay probably as much as you paid for implementing the system in maintenance costs?
So Enrique hit on there the difference between capital and operating costs, that sometimes organizations are more reluctant to put as much money into operating. But Andrew, I'm a bit behind here. Isn't money just money? Like what's the difference that we're talking about?
Yeah, it gets tricky. I mean, a simple answer, but there's a more complicated one. A simple answer is in a lot of businesses, profit margins are very slim. Think consumer goods manufacturing, or even, I don't know, pulp and paper manufacturing. Whenever you're producing a commodity, profit margins are very slim, and so there's a constant pressure to trim operating budgets. There is less generally, just in the culture of the organization, there might be less pressure to trim capital budgets, because when you invest in a new plant, you're going to spend $3 billion. And so you're spending capital money. But when you're operating the plant, you're trying to squeeze every last penny out of the operating costs, because you're up against your competitors. So that's sort of one pressure. But there's another pressure. You mentioned public utility boards. When you're talking distributing natural gas in a city, distributing electric power in a city, distributing water in a city, these are what are known as natural monopolies in economic terms, where it really makes no sense to bury 2 water pipes to every home in the city so that you can have 2 water companies competing for your business. The infrastructure cost, just makes no sense. And so you run 1 water pipe, and you have 1 water utility. But now, it's possible if the water utility is privately owned, now, or the power utility more commonly is privately owned. Now you have the opportunity to take advantage of the monopoly situation and, do price gouging on the customers and nasty stuff like this. So this is where public utility boards come in. When you have these natural monopolies, the public utility boards set the rates. They say, here's what you're allowed to charge the customer. And generally, if the utility makes a big capital upgrade, makes a big investment in, producing more infrastructure for the city, the utilities board, and it varies by every board, so it's always very complicated. But generally speaking, a lot of these boards will say, okay, you just made a $1 billion investment. The city needed that investment. You're allowed to charge the customers a little bit extra for that. Here's how much you can charge. You'll pay back the capital investment over 30 years. Your investors will be happy. Good things will happen. This is how you encourage investment in infrastructure the city needs. But often operating costs are a different animal. The Public Utility Board might say, we want you to operate efficiently. And the way we motivate you to operate efficiently is to say, here's how much, you can charge over and above the return on capital that you're getting. And all of your operating costs come out of that. And whatever profit you make, comes after your operating costs. And so which bucket the cost goes into? Is it a capital cost that can be sort of recovered easily, or is it an operating cost that comes out of my profit? Makes a big difference to the utility. But again, it's different with every board, with every utility. But generally speaking, this is why there's a difference between the two budgets. Did I hear you, talking about engaging and knowledge? I mean, are we talking about training SOC analysts, to interpret, specific alarms out of specific DCSs? Is this what we're talking about here?
Yeah, that's going to be part of it. Once again, part of it is tuning out normal alerts, which will take that knowledge from the engineers, for example, to make it easier for a SOC analyst to operate the solution and interpret, what's going on. The other piece, though, is OT systems often have different protocols. There might be different type of alerts based on what's going on, whether it's operational or security, right? So there's certain knowledge that needs to be had in order to be able to successfully interpret the alerts that are coming out of the OT side. Oftentimes, what I've seen is, we have an IT SOC analyst that might not comprehend everything, but they pair with someone that's an OT analyst. And the idea is not just to be able to interpret what's going on the OT side, but to facilitate the correlation of events between the IT side and the OT side when you're doing threat hunting or detection.
Okay, and the gap in that regard has to do with budgeting for the cost of, hiring OT analysts or training the IT people, or developing the training material if you've got old stuff there. Is that what we're talking about?
Yeah, that's actually a big part of it. Historically, you've seen the IT side starts doing security for OT. And there's a lot of false starts because the differences, right? However, I'm seeing more and more customers actually actively engaging the OT side, hiring from the OT side to help them with those pieces, and also standing up actually OT security operations groups that work hand in hand with the IT operations side.
Okay, so that's a lot of stuff that can go wrong. Do these projects ever go right? Are they worth the trouble at all?
The answer is yes. If we take an approach of tying business needs and requirements to the proper scope and to the proper solution, and we take the right steps to setting up the project, we're going to be successful. And oftentimes, you're going to find threats and vulnerabilities within your systems almost immediately after plugging in these systems. So there is a benefit. It just needs to proceed in a very specific manner to ensure its success.
Okay, I mean that's good to hear. Thank you for joining us. Before we let you go, is there a thought you'd like to leave with our listeners?
I think, going back to, is it worth it? Yes, it's worth it. Ensure that you draw the proper requirements to match your needs, and the proper planning is performed to ensure not only that you can support the project, but that you can support scaling it up. Once that's done, the sky's going to be the limit as to what you can do, see, and identify within your OT environments. And we'll be glad to help you here at WWT with your OT security strategy journey. You can reach us at wwt.com. You can go in and register in our platform. Look at our OT topic page, and you can reach me through there to engage and see how we can help you optimize your environment for security.
So that was your conversation with Enrique Martinez. Andrew, do you have a last word to take us out with?
Yeah, so I mean, I learned a lot. The sort of the big picture of what Enrique covered was be specific in your requirements, have an idea at least of how big your system really is when you're scoping the inventory part. Be aware that switches low in the architecture are very much worth monitoring and might not tolerate it, might need upgrading. And don't forget to budget for training and tuning and the stuff that is very specific to your system. I remember back in the day, I was at Industrial Defender. We had built the world's first industrial SEM. We were out there busy selling it. I remember a customer once telling me, Andrew, because we just demonstrated the product, Andrew, this product takes an enormous amount of knowledge to use. And I'm going, what do you mean? I was offended. We had built a really sweet user interface. It was just easy to drive this thing. And he said, no. He said, it's not the user interface. He said, you get an alert. It's the meaning of the alert. I mean, you get an alert that says, look, there's a chunk of the registry value in these Windows systems that should never change. And one of the values in that whole chunk of registry just changed. You're in trouble. Well, what exactly does that piece of the registry do? I don't know, but it should never change. That's all I know. Well, your response, it has to be based on what's actually changing, what's going on. That's the level of knowledge. So yeah, it's very specific, very engineering knowledge, often specific to the very specific system that you've installed, maybe even the way you've configured that system. So a lot of knowledge to include in your budget for the project, training and engineering that has to be done. So, but in the end, it's all worth it. It's, we can only optimize what we measure. We need to optimize our security posture. We have to measure it. We have to see what's going on.
All right. Well, thanks to Enrique for speaking with you, Andrew. And as always, Andrew, thank you for speaking with me.
It's always a pleasure, Nate. Thank you.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody out there listening.